Hi, welcome to the second session in the Hadoop tutorial series. I'm Ajay, and today we are going to discuss about the basics of Hadoop. Hadoop is a part of big data ecosystem. So the prerequisite for this video tutorial is to check the previous video tutorial on big data. Hadoop is the most famous distributed computing frameworks. Just a small recap of distributed computing from previous video tutorial. In case of distributed systems, there are thousands and thousands of servers connected to each other to form a cluster of servers. In this example, there are 4 servers shown as part of the cluster. In distributed systems, the data to be stored and processed gets split into many smaller pieces and gets distributed among the systems in the cluster. This is particularly useful when dealing with extremely large volumes of data. As already mentioned, Hadoop is just one of the many frameworks available for distributed computing. Based on the type of data that we are going to handle, there are 3 basic big data processing models: batch-only framework, stream-only framework, and hybrid framework. We will look at each one of these with an example. Now we have a huge amount of historical data like 10 years of bank customer transaction history, and it is required to process all this information. So we have a processing engine. The engine takes all the historical data, processes it, and then gives the result of the processing, which is again huge. Now this is called batch processing since both the input and the output is a huge batch of data. This data isn't continuously coming as a stream. So the data to be processed by such processing engines has some characteristics like it is bounded, which means you know the size of the input file, either 100 TB or 200 TB. You exactly know how big is the data, unlike stream data where data continuously flows in real time. It is persistent, which means it is stored on some non-volatile storage like a hard disk. It is usually extremely large. A framework which handles this kind of data is called batch-only framework, and Hadoop is the best example of a batch-only framework. It is called batch-only framework because it can only handle batches of input data efficiently. Stream processing frameworks are particularly designed to process a continuous flow of input data. For example, in case of Amazon, the user gets recommendations based on his current search. There would be millions of people accessing the website at the same moment, and the system needs to provide real-time recommendations to each of those million users. So the system continuously receives streams of input data, which is the customer searches, and it processes the continuous stream and gives the results immediately. So here the data is unbounded as there is continuous flow of data, and it is implemented in situations like real-time recommendation. Examples of stream processing frameworks are Apache SOM and Samza. Apart from batch processing and stream processing frameworks, there is hybrid framework, which is capable of performing both batch processing and stream processing. The best example of hybrid framework is Apache Spark. Alright, we have reached Hadoop. It is an open source framework for batch processing, and of course it's used for distributed computing. One of the advantages of Hadoop is that the servers in the cluster need not be very powerful. Rather, a low cost commodity server is enough. Having said that, it is not recommended to connect a laptop or a home usage system to the cluster. There are many functional advantages of using Hadoop over the traditional centralized systems, some of which has been discussed next. In case of centralized systems, there's a single server and all the information is stored in that server. If that system fails, then there is good chance of losing all the data that has been accumulated since the last backup. However, in case of distributed systems, each data is replicated 3 times in different machines. For example, if there is a data which gets stored in the 4th system, then the same data would get replicated in 2 other systems. The default replication factor in Hadoop is 3 times, which can be changed. This takes care of fault tolerance. More about data replication would be discussed in the next video tutorial about HDFS. We will now take an overview of how Hadoop processes the data by comparing it with the traditional approach. Usually in traditional systems, the data is stored in a separate location like a hard disk, and the data processing takes place in a powerful server. So when the client submits a program for execution, the first step always would be to import the necessary data. So the data moves from the storage medium to the processing medium for execution. The processor does the processing and then returns the result of execution to the client. The result with these kind of The issues with this kind of model is that it takes a very high bandwidth to move the data from one location to another, which also consumes a lot of time. In case of Hadoop, we have a concept called data localization, where when the client submits the code for execution, the code goes to the place where the data is stored, gets executed in the same place, and the result is returned back to the client. Since the code is usually very small compared to the size of the input data, it takes very less time to get transferred as opposed to data moving to the place where the code is present. We will be discussing more about this during the MapReduce video tutorial. Hadoop is the core, and many frameworks can be attached to it to make it more powerful. For example, when you're writing a program, you import libraries to make use of advanced features from that library. Similarly, Hadoop is some kind of your base framework, and you can import many frameworks into it to do advanced operations. We had already discussed that Hadoop is made for processing batches of data, and hence it's a batch processing framework. But we can also make it work with streams of data by adding a stream processing framework like Apache Storm. Also, we can add Apache Spark, which is a hybrid framework. If we want to work with machine learning models, we can add Mahout framework to Hadoop. And NoSQL databases like HBase can also be added to Hadoop. In fact, there are thousands of frameworks which can be added to Hadoop to do things which is difficult to achieve in its base form. This ability of Hadoop makes it really powerful. We saw that many frameworks can be attached with Hadoop to make it more powerful. But the most painful part of this is that it requires a great deal of knowledge and time to integrate these frameworks with Hadoop. Wouldn't it be really good if there is some kind of a package which has all these frameworks already integrated with Hadoop? That's exactly what a Hadoop distribution is. A Hadoop distribution is simply a package of Hadoop and many other frameworks along with it. Just like Linux is the core and there are many distributions of Linux like Ubuntu and Android, similarly Hadoop is the core and there are many distributions of Hadoop like Cloudera and so on. There are many distributions of Hadoop. The most famous among these are Cloudera, Hortonworks and MapR. Cloudera is the best selling among these. The chief architect of Cloudera is Doug Cutting, who is one of the founders of Hadoop. Hortonworks is a major player. Since Hadoop is open source, there would be thousands of developers across the globe contributing to its development to fix bugs and so on. Committers are the gatekeepers of Apache projects and have the power to approve code changes provided by anyone in the community. Hortonworks has the largest number of committers, and it is one of the biggest supporters of open source. In case of MapR, it is very handy since it's POSIX compliant. There are many distributions to choose from, and next we will discuss the points based on which we can decide the right distribution for our project. Each distribution has its own set of framework attached with Hadoop. So based on your project requirement, one must check if the selected distribution has the necessary features and frameworks. Second one is based on your project purpose. If the goal of your project is to do a prototype, then you can go ahead with the latest versions of your selected distribution, since latest version has all the latest features, but on the other hand, it might not be very stable. But if your project is long-term development, then you can go ahead with an older version which is very stable, but might not have all the latest cool features as the newer version of its distribution. A distribution might not have all features that you are looking for. Once you have done selecting your distribution, you might need to add one or two more frameworks of your choice to your distribution to meet your requirement. With certain distributions, it is easy to configure new frameworks, and with others, it might not be so easy. Open source fidelity is the degree to which a particular distribution is compatible with a new open source component. Backporting is the action of taking parts of a new version of software system or software component and porting them to an older version of the same software. This might be particularly useful when your project is built with an older, stabler version and you would like to add some advanced features already present in a new version of your distribution. The last consideration is based on the proprietary tools provided by the distribution. These tools help to better navigate around Hadoop, and you might want to investigate if your distribution provides such add-ons. Now this is an important part. Hadoop is made up of two main parts, HDFS and MapReduce. HDFS is something like a file explorer in Windows. It's just used to move data into Hadoop and read data from it. It is just used for file management. The other part is MapReduce, which is used for data processing by executing your code. For example, finding average of marks of students. There is another optional part which is Yarn for resource management. We will be discussing about all these in the next video tutorial. Alright, we are done with the second part of Hadoop tutorial series. It would really encourage me if you can like this video. Please continue watching the rest of the videos in this tutorial series. If you have any doubts, please feel free to contact me on LinkedIn, the link which is shown on the video.